Okay, today we analyzed hydrostatic forces, and specifically the case of hydrostatic forces acting on plane surfaces. So the sketch that I've shown on the right-hand side here is the setup that I used in lecture, where we've defined a new coordinate, that is y, that starts from the air-water interface and is in the plane of the surface that we're analyzing, shown here with this black surface, this squiggly. What we want to analyze is what is the effective force that is acting on this plate, F sub h. And we're going to specify that in terms of its direction, its magnitude, and its line of action. First of all, the direction, because it's a hydrostatic fluid, it cannot support any shear forces, so the direction is perpendicular to the surface, as shown in the sketch. So to be clear then, I guess I could put a little right angle mark on that, but I'm going to just leave it as is. So the direction of the force is perpendicular to the surface. Secondly, the magnitude. We can define the magnitude based on the centroid using the y coordinate. So the magnitude of the force, F sub h, is given by the pressure at the centroid times the area, which is equal to gamma, the depth of the centroid, times the area, where HC or PC are defined at the centroid of the surface. Finally, the line of action. Line of action is the location that the force acts. And I'm going to define that to be y sub h, defines the line of action. So here in this sketch, it would mean that yh would be this distance from the surface to where the force acts. And the result for the line of action is that yh is equal to yc plus the second moment of the shape of the surface divided by the location of the centroid times the area of the surface. Okay, so we have our line of action, we have our magnitude, and we have the direction of the force as perpendicular to the surface. And those three conditions together define the effective force that the distributed pressure on the surface creates.